Live again. Hi guys. Ooh. Maybe adjust the gain a little bit here. So we're looking at Saturn, of course. 9 people. Why so many Saturn lives? Yes, because I can. Hi, AstroDoc. So we are close to opposition, so I will take any opportunity I can get to talk to people about the need to get out there and look at Saturn right now, because we are close to opposition. Hello, Space Chaser. Do I recommend the Celestron CPC Deluxe 800 HD? Oof, I actually honestly haven't used such a telescope, so I would have to get into looking at the specifications of that telescope. But if it's an 800, it is a Schmidt-Cassegrain telescope, probably an 800, so that would be an 8-inch. Would be very close to what I'm using. I'm using the Celestron Edge HD 8-inch, also I think at 2032 millimeters focal length. So if you send me an email, I have a website, astroforumspace.com. If you go there, you can find a forum. Just ask me about it and I will look into it. Anthony, no problem. So let's look at the histogram here. Ooh. Yeah, we can tune it back a little bit, I think. Let's see. 275 maybe. Or maybe dial down the exposure time. Nah. Let's keep it to 20 milliseconds. Let's get that to 275. So I'm aiming for a histogram of around 80. So guys, if you're just joining in, we are looking at Saturn tonight. And why are we looking at Saturn tonight? Yeah, because Saturn is close to its opposition, meaning that in our orbit around the sun, we are passing Saturn. So Saturn is closest to Earth at the moment. So I did a couple of live streams this week already. And because amazingly we have clear skies again in the Netherlands. And I thought today would already be like cloudy, but we still have one night left. So I decided to stream. And for those of you who don't know yet, Saturn is close to its opposition. That actually means that it is at its closest distance to Earth. So I'm in the Netherlands right now and I'm broadcasting this live. You're looking at a live view of Saturn through my telescope with like a planetary camera inserted in my telescope. And I have a mount, a telescope mount, that accurately tracks and automatically tracks Saturn in the night sky. I have to make some minor adjustments to keep Saturn in the field of view, like this, but basically it's tracking automatically. You can see that Saturn is still a little bit hazy, a little bit blurry. That's because in the Netherlands, Saturn has just risen above the horizon. So right now we are maybe at, I could check, but I think it's about, maybe here I can check. Hope you can see this. Let me check the altitude. So it's still 17 degrees above the horizon. So that's still very close to the horizon. And so we have to shoot through a lot of atmosphere, actually, to image Saturn. Let me do some stuff here. Sync. I have to press sync here. All right. So Richard, hi. AstroDoc has lost his DSLR battery. Amazing. You're wasting amazing days because you do not have a spare DSLR battery? No, that doesn't sound very good. AstroDoc, I hope you will find a replacement or something. I got a manual vintage Celestron C8. Yeah. So, Space Chaser, if you have that Celestron, now would be a very good time if you have the opportunity to actually try to aim your telescope at Saturn. Seriously, I mean, it's now close to... Yeah, I have to say, the closest distance from Saturn to Earth will be on the... I think 4 days from now, on the 26th, so the evening of the 26th of August, we will have Saturn exactly at opposition, and still Saturn will then be about 1.3 billion kilometers away, so that's still pretty far away. But anyway, still, this is the best opportunity you can get, of course, to image Saturn. So I can also show you this if you like in like a solar system program I have. It's Solar System Scope. So you can see it here. Let me try and... So here you can see this is the solar system with obviously the Sun, Mercury, Venus, Earth. These are like, it's not to scale, but the positions of the planets are accurate. The positions are as they are on the 22nd of August. And as you can see here, so we are currently actually very close to Venus, but we can't see Venus because Venus is passing us right now. So Venus is only visible during the day, but the Sun is of course out during the day, so we're not able to spot Venus at the moment. It will reappear, I think in October, end of September, October, as a morning star just before sunrise. But if you look here, a little bit towards the back here, so Earth, Saturn, we are pretty much lined up with Saturn. So this is the closest we get to that planet, and we have still some ways to go for Jupiter, as you can see here. So Saturn, we're pretty much aligned now. Jupiter will be at its closest distance in, I think, the beginning of December, something like that. So it's still some ways to go, but if you actually go out at night and look at the night sky, you will see Saturn now in the southeast, and it will move towards the south in the night sky, and Jupiter will then rise right after Saturn, maybe 1 or 2 hours later, in the east, and it will also move towards the south and increase in altitude, of course. So let me go back to the live view. Oh, here we are again. It's almost 11:30. So yeah, it's a little bit hazy. Let me try to do a capture. So let's center it here in the field of view. So under good seeing conditions, I would recommend maybe imaging Saturn for about 2 minutes. Because if you go a lot further than 2 minutes, if you go for like 3 or 4 minutes, you will actually notice a little bit of the rotation. It will include, your video will include a little bit of the rotation of Saturn. So if you're going to stack those images, you will end up with a somewhat blurrier image of Saturn. Anyway, let's see, do you have any questions? Sammy, I hope you're joking. Space Chaser, I got Jupiter's great red spot through my Celestron Vintage C8, and how does it look? And Space Chaser, where are you? I mean, it also depends, the kind of image you will get. Also, it doesn't only depend on the telescope, but also on the astronomical seeing conditions and your place on Earth. Because, for instance, I'm at 52 degrees latitude in the Netherlands. So basically that means that for me, Saturn is pretty low. Oh shit, I was recording. Saturn is pretty low above the horizon. So I think at maximum, I think it will hit the highest point in the night sky in the south at about 1 o'clock at night at the moment. And then it will still be about 28 degrees above the horizon. But if you live closer to the equator, you will have Saturn much higher in the night sky. So already if you live in the south of Europe, or you live in, I don't know, California instead of New York, in California or Florida, you will already see Saturn higher in the night sky as compared to the north of the US or Canada. So that also greatly influences the kind of image, the kind of video you can make of Saturn. Because when Saturn is higher up in the night sky, you don't have to shoot through a lot of sky. You don't have to shoot through a lot of atmosphere. Oh, I'm still at AVI here. Let me change that to... yeah, why not? Let's keep it at raw. Let me change that to... I don't see a lot of difference, by the way. RGB. Nah. Let's change it to an SCR file. And let's see raw 16. So yeah, I'm basically, you can use like different settings for your analog to digital converter. So I have an 8-bit setting, and I think this is like a 12-bit. It says raw 16, but I think it's a 12-bit setting. A 12-bit setting is generally better for post-processing. But for the planets, I didn't see a lot of difference between an 8-bit, a 10-bit, or a 12-bit video. Maybe that's because Saturn's pretty low above the horizon in the Netherlands. So we will end up with a blurry image anyway. But anyway, anyhow, let's start another capture. Still looks impressive at 70 degrees. Thank you, Ian. Plenty of detail. Ian Barker, thank you so much. What telescope am I using for the live view? Yeah, this is the Celestron Edge HD 8-inch. So I'm imaging actually at native focal length. That's 2032 millimeters. But the trick I am using is that I paired that telescope with the ZWO ASI 678 color camera. And that's one of the newer and relatively affordable cameras from ZWO. And I do like the fact that that camera has a 2 micron pixel size. So being at 2 microns, so the very small pixel size, I calculated that my, like I get 0.2 arc seconds per pixel at native focal length at f10. So that allows me to like get this image of Saturn. Of course, Saturn is a super tiny object in the night sky. I could also take my 2.5 Barlow lens, and that would enhance my focal length to about 5000 millimeters. But I think that there's no point for me yet, actually, because I will just be like magnifying a blurry image anyhow. I think the astronomical seeing in the Netherlands, especially with Saturn being low in the night sky, it is maybe about 0.25 arc seconds per pixel, and I'm already at 0.2 at native focal length. So if I would like magnify the planet a little bit more, I would just magnify a blurry image. Northern California, latitude 40. Yeah, that's already 12 degrees better than I am. I'm at 52 degrees latitude, so yes, Space Chaser. Definitely go for the planets now, for Saturn at least. So I did a capture. I captured 6,000 frames in 2 minutes. That's about 3,000 every minute. Let's see. So 60 times. So I'm about 50 frames per second here. And yeah, as you can see, I have a really. Can you actually see it? Let me check if you can see Saturn. Yeah. So I have really like a small capturing area here, 640 by 480. So I think Saturn right now at opposition is about like 20 arc seconds in the night sky, angular size. So I'm at 0.2, so that's times 5. So we're looking at about 100 pixels wide here for Saturn. So let me actually show you, because this whole camera is like 3840 by 2160, so almost 4000 by 2160. So this is actually the whole camera chip. So you can see Saturn here, very small. And of course we can do something like increasing the exposure time to 2 seconds, and then probably we will see the moons of Saturn as well. So here we go, the moons. Oh, moons are all to the right at the moment. Interesting. Maybe we can zoom in a little bit, maybe get an HD sized image here, 1920 by 1080. So here we can see 1, 2, 3, 4, 5 moons on the right hand side. And let me just check with the image we're getting in Stellarium here. So that's very nice astronomy software. You can download that for free. So if I use page up, where is it? I think this one. No, I'm on my laptop right now, so I have to check if this. No, this is not the one. Where is it? Here, this one, I think. Yeah. So let me try to zoom in here. Refocus on Saturn. Let me zoom all the way in. So yeah, actually this is the situation. So Titan, that's the biggest, one of the biggest moons in our solar system actually, and the biggest moon of that's circling around Saturn is here completely at the right hand side. And we have a couple of other planet moons as well. Iapetus, Rhea is the one, Dione and Tethys, if I'm correct. So that's what we are looking at. Let me check here. So I twisted my camera a little bit, so it's focused a little bit differently. I can rotate 360 with my camera. So, but anyway, the biggest one is Titan. Actually, Titan, I think is it bigger than our moon? I would have to check. It's a big moon anyway. So when we get back to like 20 milliseconds, I think I was, then this is my view at the moment. And let me zoom in again. 640 here. And let me zoom in at 200%. So here we are. This is the planet again. How do you show the pictures? Yeah, this is separate. So I use Stellarium. So if you mean this is just Stellarium. You can download it. It's software and gives you a very nice virtual view of the night sky. So let me zoom out. Page down. So this is stellarium. And you can see here Saturn for me is in the southeast at the moment. Let's see if we already also have here Jupiter is just rising in the northeast as we speak. So yeah, you can search all kinds of different planets, deep sky objects in this software, and even I'm using this software right now to control my telescope mount, so that's also pretty neat. I can just link my telescope mount to Stellarium, and then I can ask Stellarium to slew the mount to the object I'm interested in imaging and looking at, so that's pretty nice. Maybe a little bit up. Yeah, it's still, yeah, I think we have some clouds still. This is not only atmosphere. So let me check my cloud radar actually. So this is my cloud. Oh, you can't see it, I think. I have to open it up, I think. Let's see. Go back here. All right. Let me check. Let's refresh. So my laptop is actually pretty slow at the moment. Oh, it doesn't. So probably because I'm streaming from my laptop. I'm asking him to do too many things. Oh, here we are, here we are. So, oh, we have to go up a little bit, wait. Oh, it's completely frozen. Can he go up? Go. It doesn't. Oh, interesting. Oh, no control whatsoever. Oh, here we are. So I'm here in the Netherlands. So in the center here, this is Belgium, this is the north of France, this is Germany. And you see a lot of clouds at the UK at the moment and Ireland. And they are moving towards the Netherlands. But still we have clear skies, so that's nice. Relatively clear skies. So let's get rid of that cloud radar here. Nice to see that somebody has a clear sky. Yes, Andrew. So you're, yeah, UK clouds for 3 months. Yeah, I also heard because I went on holiday to Slovakia and the Czech Republic, and it wasn't too bad, the weather. We did have some clouds, but not too much rain, and also some good, like, clear. We didn't have any super clear nights, but we had like sunny days, so it was sufficient to go swimming and walking and hiking, that kind of stuff. But I heard from people in the Netherlands that they had 3 awful weeks this summer with lots of rain indeed. So that's also why I am live streaming at the moment and showing you this, because I know for sure that tomorrow and the day after they are predicting rain. So that's why I have a couple of live stream sessions to show you that Saturn is in opposition right now. I can show you this, and I don't know when my next opportunity is going to be. I know now we have the opposition of Saturn, but also I think we have a full moon like in the end of the month, the end of the month, the 31st of August. So that's in about 9 days. We will have a full moon, and that will be a super moon. So that moon will be a little bit larger as compared to a normal moon, a full moon. So that's also a nice opportunity to do some imaging. Actually, I prefer imaging the moon when it's not in not a full moon actually, because then you can see the shadows on the moon. So like for instance, if you look at craters, you look at mountain ranges, you can see the shadow of those mountain ranges being cast on the surface of the moon as well. And when you have this full moon, you will not see those, like these kind of shadows. Anyway. The Celestron CPC mount is more accurate than the Advanced VX, but I would need to add a wedge. Yeah, it's probably because I know that the regular Celestron SCTs, they all have like this LS system mount. And yeah, you can do some planetary imaging with an altitude azimuth mount, but when you are going to look into deep sky astrophotography, you're definitely going to want to have an equatorial mount. So I know that there are wedges available for an altitude azimuth mount, and that goes yeah. It is nice to have the wedge, because then you can like simulate tracking of a regular equatorial mount, but I don't think it has auto guiding, but correct me if I'm wrong. So to really take like multi-minute pictures of dim objects beyond our solar system in the night sky, you would need to have an equatorial mount. And yeah, there are some mounts that can track very precisely. They have special encoders, but those mounts are typically like a couple of $1,000, easily 4, 5, 6,000. And most of us actually don't pay that much for a telescope mount, but they use auto guiding, meaning that you have a separate telescope with a separate camera that is tracking a nearby star, and every time the star moves a little bit, it will send a correction signal to your telescope mount to keep the deep sky object exactly in the field of view. And that's how you manage to take like detailed deep sky images, long exposure images. And I don't think that if you add a wedge, you can track in equatorial mode, but I don't think it has then auto guiding. But correct me if I'm wrong. Anwar, which software is it? I'm using actually SharpCap to look at Saturn at the moment. So SharpCap is a pretty famous, at least in my area, it's pretty normal standard software people use to actually link their planetary cameras to like viewing and capturing software like SharpCap. So here I can just connect my camera, I can manipulate the exposure time and the gain on that camera, and I can also record videos, in this case of the planet. So that's pretty nice. And you can download SharpCap for free, so that's also cool. The one thing is that there is a paid version. I actually have a pro version, and that gives you the opportunity to also do some extra stuff like polar align your telescope mount. And I use that quite often actually. Moon imaging is better when you see the Terminator. VJ Air is in the house. Hello, VJ Air. So I'm taking another capture here. I'm taking some captures using the 12 bits or the 12 bits option, and I've taken some captures using the 8-bit option, and I'm actually curious if I will see a significant difference when I'm post-processing the videos. I will look into that. And yeah, by the way, I'm working on a detailed planetary course. I'm going to be putting that on my... I already have a couple of people who joined my channel. Thanks if you're watching. For being joining my channel is $2.99, $2.99, almost $3. And what I'm going to do is I will put some stuff on the members, for the members there. So I'm working on like a detailed planetary course, maybe 3 or 4 videos in which I will explain everything I know about capturing the planets in the night sky, basically. And I will also share my data. So I'm capturing Saturn right now, but I will share videos of Saturn, Jupiter, and Mars on the members site. So if you join the channel, you will get to download that data, and yeah, you can try and process the images with that data if you want. So yeah, that's what I've been working on for the past couple of, actually the last week. I got back, I think, about 10 or 12 days ago from holidays. Anwai is new to this field. I have a 9.25 on my EQ6R VJ Air. Oh, I'm a little bit jealous. You have more of a longer focal length. But where do you live, VJ Air? Your off-axis guider, yeah. I still use a regular telescope, like a guide scope, on my Edge HD 8-inch, and I never had issues. But I know that a lot of people do prefer an off-axis guider, especially when they are imaging at these long focal lengths. And by the way, you probably saw it already, but there is this new camera, the ASI 2600 Color Duo camera, which actually has like a large sensor to capture images, but also an extra additional sensor to use as a guiding camera in one camera. So that's pretty awesome. Would love to check that out as well. So that would eliminate the need for an extra guide scope or an extra off-axis guider solution. Very curious how that would work. You are in Southeast England, VJ Air. So you're close to me. That's London, right? Or not? Anyway, I think like in terms of distance, we are about what is it? Maybe 150 kilometers apart then. So you just have to cross the English Channel to visit me. Actually, we call it the North Sea, but yeah, pretty close. So now we have somebody with an Edge HD 11-inch. Andrew. Hello, Andrew. And he also works with an off-axis guider. Yeah, I'm actually not guiding at the moment. For Planetary, I'm just tracking. I did some I did polo line my EQ6R Pro, but I'm just tracking the planet without any auto guiding, and it's doing a pretty good job. So I can take 2-minute videos of the planet, and that's enough for me. Oh, I was capturing again. I keep on forgetting that I'm capturing because I have these 2-minute captures. Okay, let's do one more then. Let me try and put it in the middle for the next capture. Let's immediately start it again. 2 minutes, right. 60 miles north of London. I think when you are in London, or you're also at 52 degrees latitude, right? So our biggest enemy is maybe not our focal length, but just the astronomical seeing, as you can see also here. With these planets being low in the sky for us, it's pretty difficult actually to get a very clear view of the planets. I would love to take my telescope to the south of Spain, or maybe the north of Africa even, to be closer to the equator and see these planets high up in the sky. That would, I think, would make all the difference. Yeah. Of course, I would also like a 9.25 HD or a C11. But then every time I check out the price, I just keep my Celestron 8-inch. So if you have the money and you want to go for it, of course, I think a larger or like a bigger aperture, a longer focal length definitely will give you a better, a higher resolution picture, of course, of the planets in the solar system. No doubt about it. But also, yeah, like you will need like a good quality astronomical seeing, right? So good will be like 0. I think it's 0.25 arc seconds per pixel. Actually, I'm already at 0.2 arc seconds per pixel, and if you look at the image, you still see a pretty blurry image because I'm shooting through so much atmosphere, and probably there are also clouds. So I think it's very interesting to see a lot of discussion on aperture and focal length on all the astrophotography fora. But I think the main thing that is actually giving us good or bad final pictures is the astronomical seeing. I think people often forget about that. I think we have pretty bad astronomical seeing actually, and then you can just as well. Sometimes for like planetary conjunctions, I have used my 500 millimeter focal length apochromatic refractor, like a lens-based lens telescope, and of course the planets are smaller, but the image quality isn't that much different, and it should be. So that basically means that a lot of times we have our astronomical seeing is not so good. But hey, you only need 1 or 2 minutes or 3 minutes of good quality seeing to end up with a good picture of a planet. So it's always worthwhile to check it out, especially when planets are in opposition or close to opposition. So that's what I'm doing at the moment. Sombrero Galaxy. Is the Sombrero out right now? Could be. Of course, the main, I think a lot of people will go imaging the Andromeda Galaxy again, M31. It's always, I think it's one of the biggest targets you can actually capture in the night sky. And a good time for it would be September, October, right? In fall. Mostly it can find a star. Yeah, that's also, I think, with the off-axis guider, you do maybe need to search for a star because you're at a focal length, I don't know, 1500 millimeters or something. Yeah, most of the time you will actually have a star in the field of view. But there are some areas where you maybe not, you have an issue. I don't know. So guys, if you tuned in a little bit later, I'm just tracking Saturn in the night sky because Saturn is very close to Earth right now, or actually it's closest it can be in 2023. So it will reach opposition on the 26th of August, on the night of the 26th and the morning of the 27th of August. It's right now, it's the 22nd, so 5 days to opposition. And for those of you who don't know what opposition is just that the planet will be at its closest distance from Earth. So I have this solar system program here so I can show you this. So this is like the planets are not to scale, but actually the positions are accurate. So as you can see, Earth is here behind the sun. You cannot, I try to line them up, but anyway, you can see here's Earth and here's Saturn. So you can see if the Earth is exactly in between the Sun and Saturn, it also means that in our orbit around the Sun, we will pass Saturn. So Saturn is, the distance from Earth to Saturn is closest as it can be in 2023 in the last week of August. So definitely if you have a telescope and you want to look at Saturn, this is the best week to do it actually. And also, of course, the first or the second week of September are pretty good times to image Saturn. Still, Saturn is 1.3 billion kilometers away, so you will need, the best thing you can have is a telescope with a big aperture and a long focal length. I'm using a telescope right now with 200 millimeters of aperture, so 8 inches, and a focal length of 2032 millimeters. And that's the image I can show you. So I'm showing you a live view. What am I doing? I'm showing you a live view here of Saturn through my telescope with a planetary camera. And that planetary camera is called the ASI 678 color camera. So that's for the folks who tuned in a little bit later. So let me try to get it back in the... So Saturn is getting higher up in the night sky, and I'm hoping that the image will improve once it gets higher in the night sky, because I have to shoot through less atmosphere. Also, a lot of folks at my latitude, like 50, 60 degrees latitude, that would be in the northern hemisphere, they also use an atmospheric dispersion corrector. I didn't use it yet, but it's supposed to give you a better image when planets are low in the night sky. So that's maybe also something you want to look into. John, thank you from the West. Thanks for joining, John. I've been getting my screen frozen while trying to enter comments. Oh, is that, am I actually still streaming okay? I didn't check the quality of the stream. So maybe I'm also, it says good quality, hopefully. Okay. So guys, if you like these kind of live streams, give the video a like. And of course, I think this will be like only this week that I will do some live streams because Saturn is in opposition. Of course, you can also expect like other, like higher quality videos where I actually prepare the video and actually prepare a script. But I think once in a while it's also nice to get a couple of live streams out and to talk to you directly. So yeah, ask me anything you want. So I will be imaging Saturn for I think about half an hour more, or maybe it depends a little bit on the astronomical seeing. Right now it's quite good, yeah, at least for my area. Let me try to take another capture. Oh, now it's wobbling a lot. That usually means that clouds are coming. What can I... Yeah, once again, I could show you this. Let me show you the wide field view of Saturn at the moment. So here I'm changing my region of interest, as it is called. So now we have Saturn at a smaller size, but that allows me to like take these 2-second exposures and also image the moons. So here we actually see 5 moons, with the biggest one here on the right being Titan. So they're all on the right hand side at the moment. Very interesting. Can we go a little bit further, maybe go up to 5 seconds? Maybe we can also see some stars behind Saturn. Let's see. Not really. And yeah, these stars, these moons, I think we can definitely see Titan, but I'm not sure about the other 4. So I did this already. I zoomed in. Let me do that again. Hello. Yep, let me zoom in here. So it's supposed to be 1, 2, 3, 4, 5. Yeah, that's Titan, Iapetus, or something like that. Rhea, Dione, and Tethys, I think. So these are probably the biggest moons, and Titan being the biggest of them all. So these are the moons you're seeing. I see also a vague blob here on the left. Is that actually a moon? Could be. Yeah, could be Enceladus. But Enceladus is super small, right? I don't think we can see it. Anyway. So let's go back to the planet itself. So I'm usually between 15 milliseconds and 20 milliseconds when I'm imaging Saturn. Let me zoom in again. So here we go. So I'm actually reducing the region of interest and then zooming it in at 200%. So here we are again. Streaming is fine. Great. Is that a sixth moon on the left? Yeah. It does look like it. But how big is Enceladus? I thought it was the tiny... I know there's a lot of... there has been a lot of news about Enceladus because they actually... I'm not an astronomy guy, but I saw that they had some like water vapor. So it's because of the gravity of Saturn, the ice moon is actually the ice inside that moon is actually has melted. There's an ocean inside, and then also there is it spews these kind of water vapor into the atmosphere. And I think was it. Cassini, I think Cassini went through one of these water vapor clouds. Did they? And they did some recordings and they find some biological markers, something like that. But how Enceladus? I don't know how to write it. Enceladus. Okay, moon of Saturn. So how big is it? So it has a diameter austral. So it's a diameter of about 460,000 kilometers. Okay. Diameter 500 kilometers. But our moon is 3,500. So that's 7 times, our moon is 7 times larger than Enceladus. Yeah, still could be. Can you include equipment info in the description? I will add that after the live stream. Or maybe I can do it right now. But I'm actually using Celestron Edge HD 8-inch with a ZWO ASI 678MC, like a color camera, at native focal length. So that's the image you're seeing. And I have been working on a more structured video, or like a video where I explain what kind of equipment I'm using. I will release that tomorrow, I think. And I will include the description of my equipment in that video, like in the video description below, so you can check it out. Actually, I polar aligned my telescope mount yesterday and I noticed now a little bit of drifting. It's not much, but I have to correct for that drift once in a while. It's not too bothersome. Let me check out the histogram again. Oh, it's all over the place. Maybe I need to go back a little bit. Is it logarithmic? Yeah. 15 milliseconds. Yeah, it's a bit higher in the sky, so maybe. Nah. 17? Yeah, it's still okay, I think, at 20. I don't want to overexpose Saturn when I'm capturing it. So I think 20 is maybe a little bit too much right now. So maybe 19. So you see the red is going crazy. Probably because of the clouds, I think. Anyhow, let's take another capture here. They find life. I hope they find life. Yes, that would be news. Out of this world. They have seen all kinds of like biomarkers and that kind of stuff. So the, how do you call that? Like the elements that where life came from or something like that. So yeah, maybe there's just a couple of maybe we will find life on Mars or one of these moons. I know that there, yeah, Enceladus obviously has some biological markers, I guess, and there's also talk of mission to Europa, so one of the Galilean moons of Jupiter, where you also have a big ocean inside that ice moon because of the friction caused by Jupiter's gravity. And that could also be, I think most of the Galilean moons have oceans, right? And we have, of course, Io, which is super active. A lot of volcanic activity on Io is taking place. So, yeah, who knows? But I think maybe the first signs of life will be like that. Maybe small bacteria or something we can find. But of course, it's still a far cry from. I don't know if I would call us intelligent species, but at least like the kind of species that can actually travel to other planets or maybe build satellites or build a communication system. So I don't know about intelligent life. I mean, I always think about it like uh, if the universe is already 13.7 billion years old, then life has had a lot of time to develop already, right? So we are here on Earth for about, what is it? 4.5 billion years? Or at least when the Earth is like 4.5 billion years old. So, and the universe is a lot older. But anyway, the first stars, they didn't include materials to make planets. So yeah, it could be that there is intelligent life out there. I don't know. Would be very interesting to see if we can make contact. I think I will not be able to do it with the Celestron Edge HD 8-inch. Yeah, Andrew, Mars seems pretty dead. Yeah, that's. Yeah, so if they are going to find something, it's when they are going to drill in the they are already drilling in Mars, right? So maybe below the surface. I know that they have like already some promising rocks. They dug them up with one of the rovers, and they are planning on returning those rocks to Earth, right? So that's pretty interesting as well. So I would love to see a mission, like a collect mission of those rocks. But I don't know. We never been to yeah, we have been to Mars with the rovers, but we don't have a spaceship for humans yet, right? So everybody is trusting that spaceship will be the one to take humans to the moon and Mars again. But let's first see if they can get it off the ground into space. Didn't go so well last time. The odds are very high. Yes, Andrew. Yeah, I think there's this one. On the one hand, yes, because there are many stars, so there are billions of stars, and around each of the star, on average, there is a planet. So, and there are billions of galaxies out there. So definitely, you would expect then on one planet or another to have like there has to be like some kind of species that has been developed like far enough to communicate and to travel into space and whatever. But on the other hand, we didn't hear from them yet. So maybe it's harder than we think. Or they're just maybe keeping us out of the communication loop because we are still too stupid as a human species. maybe maybe they're waiting for us to develop a little bit more and stop killing each other, that kind of stuff, before we can actually communicate with other aliens. I don't know. So I think that our star is like a third or fourth generation star because of its size. I know it's a main sequence star, so it's a pretty common star. But I know it's. I wouldn't be able to say it. I will. I need to read more astronomy books. It's definitely at least a second generation star, maybe a third or a fourth could be. Yeah, but Green Cat 100 years behind us. Yeah, of course, because we have the time difference. But hey, I mean, 100 years is not so much if you think about the 4.5 billion years we have. The Earth has been around, and Homo sapiens has been around for 300,000 years. So you just would expect that there would be that the universe would be teeming with life actually. So it is pretty cool what they are doing with the James Webb Space Telescope. They can actually look at the atmosphere of exoplanets and actually see if there's an atmosphere at all, and if there's water and all the elements necessary to um, for life to develop on those exoplanets. So that would be a good indicator on where to go, where to look some more. So if we have mapped enough planets where actually there could be life, all the circumstances are right, then would be interesting to build maybe larger telescopes. But still, of course, something like the TRAPPIST-1 system is still 40 light years away, something like that, 45 light years away, something like that. And we cannot travel at light speed, so to take 45 years to send a message, another 45 years to get a message back from one of those planets. So I will not be able to hear the response. Anyway, the universe is a pretty big place. So 1.3 billion kilometers from here to Saturn at the moment isn't that far actually. Yeah, the speed of light. So we just have to invent warp speed, right? They already did in Star Trek. And there are some papers on building a warp engine. And that's pretty cool. But it required like the energy of the sun, something like that, to actually build a spaceship that could go at the speed of light. And then, of course, the forces will be so big. I mean, I know that there was in the 60s and the 70s they were thinking about putting some big nuclear engines on spacecraft that would then be able to go like a quarter of the speed of light, something like that. So I think the nearest star system is, what is it? Can you remind me? Ah, why did I forget? Let me check. The nearest star, Alpha Centauri, of course, yeah. And there was actually talk about a planet in the Alpha Centauri system that could be habitable, in the habitable zone. So that's also pretty interesting. So that's, and I think that's all only like 4 light years away, something like that. So then it would take 4 years to send a message and another 4 years to get it back. That's doable. But that is, of course, if they would understand like our communication, our way of communication with light speed. Anyway, but I'm venturing far off. I think I will like try to sign myself into another master's of or a bachelor of astronomy. That would be great. Learn more about those things. Saturn looks good. Leon. Or Leon, thank you. So yeah, we are looking at Saturn. It's getting higher and higher up in the night sky. So I'm actually hoping that the image, the video of the live view actually I'm showing you will improve a little bit. I think it did a little bit. But as I said before, I'm in the Netherlands, in northwestern Europe, actually close to the UK. And being at 52 degrees latitude, we have Saturn pretty low in our night sky, so it doesn't climb beyond 20. I think it's like 26 or 27 degrees from the horizon. So I have to shoot through a lot of atmosphere, and yeah, the Netherlands in summertime we have a lot of haze and clouds that diminish the quality of the view, but still. I'm already happy to see Saturn and its rings, and I'm hoping to get one good video. So I'm taking 2-minute videos of Saturn with my telescope and planetary camera. And I'm going to process them in, I'm still using AutoStacked and Registax because I'm just used to using these programs. I have some free tutorials on my YouTube channel, so if you're interested in how to process pictures of the planets, just Google AstroForum and AutoStacked on YouTube or AstroForum and Registax, and you will be able to find those tutorials I've made. Anyway, let's move back. So let's take one more. So guys, if you like these kind of live streams, give it a thumbs up, the video. I really appreciate that. And yeah, as I said before, I'm also I'm going to work on like a members kind of thing. So you can join the channel for $2.99, so almost $3. First of all, that would enable me to buy 1 or 2 cups of coffee to make all these videos. And in return, what I want to do is to put some dedicated tutorials about astrophotography on that members channel. So I will be, first of all, I'm working on actually a planetary course where I put in all the knowledge I know about how to image the planets in the night sky, what kind of equipment to use, best times and best places to image the planets, and also tutorials with data that is available so you can practice in processing videos of the planets. So that's what I'm working on first, and I will then continue to put like tutorials, and I will continue to share my data on that for $2.99 a month. So if you want to join, you're welcome. If not, I will still of course, make plenty of videos on my regular channel. So if you subscribe to Wido's AstroForum, you can expect, yeah, I'm right now I'm doing live sessions, but most of the time I'm doing weekly videos where I test new kinds of products, new kinds of telescopes, mounts, cameras, or just talk about like new software programs that are available, that kind of stuff. It's all related to planetary imaging and astrophotography. And sometimes I also do some moon imaging as well, and also solar imaging with my Daystar chromosphere. Oh, Leon, I struggle folding my t-shirts, never mind space and time. Yeah. Good one, Green Cat. And Leon, I used ZWO Studio to make an image and it gave me very good results. Yeah, I'm actually, because there are some different programs out there as well. ZWO Studio, I didn't try that one yet. Thanks for the suggestion, Leon. I will look into that as well. So let's do another capture here. Start, 2 minutes. Yeah, let's hope for the best. Let me check out my cloud radar. Where is that thing? Oh yeah, last time it just froze. Ah, here we go, here we go. Well, there are some clouds coming here. So you see here again. Oh, this is like, it's an old, can I refresh it? A lot of clouds in the UK, indeed. Oh no, this is the most current picture. So we have a cloudy UK tonight. France, the north of France is actually pretty... this is the issue. You see here, you cannot really see it, but there is a little bit of haze in the night sky, and that's definitely not the best to have when you are doing planetary imaging. You want the sky as clear as possible, but still, we do see Saturn, so that's nice. Germany is also pretty good right now. And Switzerland, the north of Switzerland. So it looks like we are continuing to have clear skies. So maybe I can switch to Jupiter. So another capture done. I don't know how many gigabytes I have left on that. So I have actually a laptop, a small PC. I will show it in one of my videos about capturing Saturn. So I have a little PC on the side of the telescope mount with a very short USB 3.0 cable. So I've learned that the shorter your cable is, the better, or the higher your frame rates will be when capturing planets in the night sky. You want your frame FPS to be as high as possible to capture more of those frames, and then you have a higher probability to get some high quality frames you can then select and further process. Okay, let me do one more. Is this actually the center? It is. Dead center. So Let's do another capture. Let's hope for the best. Oh, Andrew. Yeah, I also saw that. That's way beyond, I think, amateur astrophotography. But somehow, of course, you can. There are all kinds of reports on astronomical seeing. So I'm guessing that they use the laser to actually see the how much the image is deviating. I think you have arc seconds. So usually the astronomical seeing is worse than 1 arc second on average in the Netherlands. But it, of course, it fluctuates a lot throughout the night. So at some point you will have better astronomical seeing, and at some minutes you will have worse astronomical seeing. And somehow, I think that laser can then detect the distortions, the deviations, and then it will maybe send corrections, I guess, to the telescope itself. And maybe those big telescopes, I don't know if they have separate mirrors or something. Maybe they can then adjust for that atmospheric distortion, but it's way beyond my my knowledge. It's actually super cool that they have found a way to actually partly eliminate the effects of bad astronomical seeing conditions. But of course now they have to deal with all those communication satellites as well. As do we, as amateur astronomers. Jupiter was visible in the south this morning, early daylight. Yeah, I think Green Cat that I showed you, can show you again. So this is Stellarium here. So we are now right now we are locked on Saturn. So let me zoom out. So we're now, it's almost 12:30 here in the Netherlands. So if I move to the left, so you can see here, Jupiter is now rising in the east for me. So indeed, it will actually, if we look at the equatorial grid, so it will move up towards the south indeed. And so the planets and the stars will move from east to west, of course. So I think early morning indeed it will be maybe about highest in the sky in the south. But like I said before, let me also show you that other, like the solar system program. Solar system scope it is called. So here, this is solar system scope. Let me get to it. So this is why you see Saturn now is at opposition, so it will be highest in the sky around midnight or a little bit after midnight, depending on. We have like this summer. How do you call that? Time, like daylight saving. It's called in English, I think. Time. So Saturn will be highest in the night sky for us at about 1 o'clock at night. But you can see Jupiter here is still far to the east, so it will only be visible until dawn when it is in the south. But when maybe we can turn this. How does this work? I can press play. Yeah. So let's get this thing moving. So let's see here. This is September, so we will be moving closer to Jupiter. So Jupiter will rise earlier and earlier on in the evening, I think in the south. And then here, it's like in November. Oh, November, maybe we already passed it. So I think it's in opposition at the first week of November, more or less. And yeah, that would be the best time to capture Jupiter because the distance is shortest in 2023 between the Sun and Jupiter then. Anyway, can I do here actual time? Yeah. So this is the position of the planets at the moment, with Saturn almost being at opposition. So for those who find it annoying, I apologize for the third live stream I'm doing on Saturn, but I think this week is the only week I will have to do the live streaming of Saturn. Knowing the weather in the Netherlands, we will be having clouds again. Yeah, Hogart, always the Nina thing. So yeah, I wouldn't recommend SharpCap for deep sky astrophotography. Most of you have been using Nina. So I think there has to be a point where I actually install and use Nina as well, because just to get rid of all those comments. So I'm still using Sequence Generator Pro, which always worked for me and still works fine. But I think Nina's free, right? I think for SGP you have to pay like $50, something like that. And Nina is freeware, I think. So yeah, that would be a big advantage right there. So for deep sky astrophotography, most of us use Nina at the moment. Still, I would say Sequence Generator Pro is very nice as well. And for planetary imaging, I think most use Fire Capture and SharpCap. But like some people say in the chat, you also have the ASI Air at the moment that also can capture videos. But I saw some comments that the frame rate per second, the FPS, is a little bit low on the ASI Air. I have to check that out. Hogart, you won't go back. You are very sure of yourself, Hogart. Best portable power supplies. I do use like a better. I can. Oh, I can do a video on that. That would be great. Thanks for the tip. Actually, that's always a trade-off, right? If you have like a larger battery, it will also be heavier. So I do have one battery I really like. I want to show you the one I have. I have to look at the exact like type number. But it allows me to, I use it in combination with my refractor telescope and the CWO AM5 telescope mount. And I'm able to use that battery throughout the night, at least in summertime. And it's super portable. It has a live PO kind of battery. Now, anyway, I will show it to you in one of my videos. It lacked some observatory features that I need. The ASI Air? I mean, what kind of features did you miss, Andrew? Oh. SharpCap for planetary. Good focus tools. Jackery 500, that's the battery. All right. So what do you think? Is the view getting better or worse? I don't see a lot of difference. Actually, I think I've been streaming for more than an hour now, so let me check on what is now the altitude. So I'm now at 13 now. Really? As alt. 13 degrees. So I'm still only at... Is that true? Let me check. I think it's true. So yeah, that means it's only 13 degrees up in the sky. So that's why it's still wobbly. Oh no, let's not do that. That's kind of tricky. Anyway, so it's not at its highest point in the sky yet. Dome control. VJ Air, what kind of stuff do you have? I don't have any dome. Yet. Not yet. The ASI Air plus 8832 frames per second, really? So that's enough to do some planetary imaging. The exoplanets plugin. But VJ Air, you're not going to be able to resolve those exoplanets, right? Or what kind of telescope were you thinking about using? Oh, you don't have a dome. Oh, sorry about that. I thought you would have because you noticed you knew that dome could be controlled from. But actually, Sequence Generator Pro can also control a dome. But I mean, it's also I have been like my astrophotography journey is as follows. So first I had a refractor telescope with a Celestron AVX mount, and I moved on to like the Edge HD 8-inch because I got this aperture fever. I wanted to have a longer focal length to be able to zoom in on some of those tinier deep sky objects and also the planets. Of course, I could try to go further with a C11 and a C9.25 or something, or maybe even a 14-inch. But I really don't know. Yeah, first of all, of course, it's pricey to you can buy a small car. And I'm not sure if the astronomical seeing in the Netherlands will show me any benefits beyond like the 2000 to 4. I mean, I can go as far as 5000 in focal length. I don't think the astronomical seeing is great here in the Netherlands, and I'm really unsure if I would get a better view. So actually, I've been thinking the other way. I've been thinking about more portable gear to use, and maybe also go back to using small refractor telescopes with a shorter focal length to really get these wide field images of whole areas, like the Cygnus clouds, for instance, in one picture. But anyway, that's always you always want some new stuff in astrophotography. It's a never-ending journey, I would say. You have dome, and the one thing about a dome is that you need to put it somewhere, and then that's your location for every imaging night. So I still have this dream of putting my telescope gear into the back of my car, or I would like to have a van and just go to really a dark sky location, because I'm in the city here, and actually the whole of the Netherlands is pretty awful when it comes to light pollution. So I would really like to travel to darker skies, and then with a mobile setup like a ZWO AM5 or even the AM3. Is that out already, that thing? I don't know. But anyway, that would become possible. And even I have thought about using my bike. I have like a bicycle, of course, in the Netherlands, being Dutch. So if you have a very lightweight gear, then you can go like outside of the city. But of course, you will have to spend a night outside or in your car. Anyway, here's the question I always get. Did you ever use an atmospheric dispersion corrector? Leon, unfortunately, no. I should really do that, and thanks for reminding me. The old toilet tent? Oh my god. What's your most recent astrophoto? Pooh. I think I did the North America Nebula again for like the third time. I started with the 81mm refractor on the Hack 5 Pro. I now have the Edge HDL 11-inch and the AQ8R Pro. Yeah, Andrew, with that kind of gear, I definitely understand you would also like to have an observatory if you have the money. I mean, the EQ8R Pro, I imagine is pretty. Is it? What is the weight of that thing? Oh, you already have an observatory, probably. Yeah, then that would make sense. So I think that then you're done maybe with a C11, and you can of course use a focal reducer and maybe even how is the thing, the Hyperstar? Do you use that as well? Anyway, then you're about done. You can use your C11 in any way you see fit on a very stable mount. Heavy. Yeah. Can you pick it up? I know my EQ6R Pro, I think I can carry it around the house, but I limit myself to my backyard and my balcony. And when I have to go up the stairs, I already have some back, how do you call it? My back hurts already. So actually, getting a ZWO AM5 again, it was like refreshing. It reminded me of my first, like the Celestron AVX. So very lightweight. It's even lighter than an AVX, the CWO AM5. So that's cool. But yeah, these harmonic drive mounts, of course, still we have these questions about durability. And I have tested the AM5, and in terms of tracking accuracy, like with auto guiding and multi-star guiding, I'm at about 0.6, 0.7 for that AM5 mount. And that's of course also when there's a little wind outside. So when it's like there's almost no wind, then the mount doesn't experience any issues. But when you are experiencing some wind, you need a more stable tripod and maybe also some counterweights. And then, of course, you lose the advantage of that lightweight mount. Anyway. AstroDoc is informing me that I should capture. I'm capturing AstroDoc. I'm doing these 2-minute captures. Maybe you cannot see it, eh? It's like on. Oh, you cannot see it because my webcam is in front of the timer that shows the capturing time. So I'm now 1 minute into recording this image of Saturn. I think you're right, actually, and that's also what I was hoping for. So when Saturn gets higher up in the night sky, I might have a decent image, hopefully, to work with. A decent video, I have to say. Philip's stargazing book. Congrats, Andrew. So I've been working a lot because I'm in the Netherlands. There are some Dutch astronomy and astrophotography magazines. They have been publishing my stuff, so that's always very nice to work with. I work together with an astronomer, university astronomer, who could tell a lot about the images I took from. I think I had Pac-Man Nebula, and I think some basic stuff like the Rosette Nebula, and, with a nice story of what we were actually looking at. So that's nice to cooperate with with like astrophotographers cooperating with astronomers to have a good story and a good photo. That's very nice. And yeah, of course, I have this one APOD. I think it's already like 2 years ago. I couldn't believe it actually. I had an APOD on the Pac-Man Nebula with my Celestron Edge HD at with a 0.7 reducer. So I made a narrowband picture, and but I cheated a little bit because I took a narrowband picture and I took out the visible stars. So that would be like just a starless image you can create. And then I overlapped that picture with a picture taken by, I don't know, a space telescope that also was imaging the nebula in ultraviolet light and in infrared light. And then you can actually see the newborn stars inside that nebula as well. So I blended that. And so I wrote about like, hey, I used some scientific grade material and like a starless picture I took from my backyard to make like to show you the nebula in from infrared actually to visible light to ultraviolet light. And of course that also corresponds with the different things you can see inside that nebula. So they liked that story and then they published the Pac-Man Nebula picture. But anyhow, there are so many websites and spaces where you can actually put your photos, and everybody posts on Instagram right now, right? And Facebook and whatever. So the main thing I want to go for is just make informative videos on for new people to come in and explain to them what we are actually doing, how to capture planets, how to see planets, how to track them, how to capture deep sky objects, that kind of stuff. Are you going to do a quick slew to Jupiter? Yeah, I was actually thinking about that. A moon image 10 years ago. Congrats. Green Cat, you're also into the business a long time, I guess. So I've been into astrophotography since 2016, actually. So that's about 9 years already. My God. Time flies. So do you want to see Saturn? Maybe I can try to slew to Saturn right now. But actually Saturn is getting, or to Jupiter, I have to say. But let me just, yeah. Let me just get one more capture here. It's almost 1. I also want to go to bed at one point. Need to do some stuff tomorrow, unrelated to astrophotography. Thanks, Andrew. I intend to make a cool video for shows. Well, I hope you let us know what you're going to work on, VJ Air. Shall I slew to Jupiter? That's now the main question. So I'm taking here my last capture then. Let's try to slew to Jupiter. Did I help you, VJ Air? Thanks for commenting on that. I don't remember. I get emails all day. So if you want to contact me, you can send an email to astroforumlive@gmail.com. Or you can look at my website, astroforumspace.com, and then I have this contact form you can just fill out. I'm always happy to respond. My dad bought me my first scope when I was 10 years old. Green cat refractor. Aha. Now we understand. So actually I didn't have a telescope when I was young. And I also think the technology has advanced quite a bit. I saw some people in the 90s, they were without a DSLR camera still. Taking pictures just using like a old-fashioned, how do you call that, photo roll. And I also read somewhere that people used to manually guide. Like we use auto guiding in PhD2 or the ASI Air for guiding right now, but people used to look through a finder scope actually and looked at a nearby star and made manual corrections to the mount. So hats up for them. So okay, this is, I'm going to do that one slew. I think Saturn is almost at its highest position in the night sky anyway, so the view will not be getting a lot better. Jupiter is still close to the horizon, so let me that's the EQ6R. Let me try and slew to Jupiter. Maybe I have to make some small corrections and go to my telescope. Let's sync this. I'm actually using Stellarium right now to just control my telescope. Oh, it stays there. Okay, whatever. Here we go. Jupiter, where are you? In the east. I don't know if it's actually above. I have some trees in the east. Hopefully it's above that tree line. Right. Current object. Slew. Uh-oh. Here we go. Let's see if we can see anything. It's always a bit tricky with 2000 millimeters focal length and a small planetary camera. Oh, I saw something. Oh. I think I have to go upstairs to really fine-tune the view. Oh, I can actually maybe check this out. Let's put it at the biggest region of interest I can have. Oh, we are in luck. Jupiter. Close above the horizon. Let me try to center it for you. Oh, what am I doing? I need to go here and then here. Okay, here we go. So let's look at the moons first then. Let's do like 2-second exposures. Ta-da! So the 4 Galilean moons. 2 on the left, 2 on the right. So let's see what they are actually. Alright. Let's zoom in a little bit here. So here we go. We have Europa and what's that? Airy? No, that's not a that's a star. So we have Europa on the right hand side then, and Callisto and Ganymede on the left, and we have a star actually. Sigma Arri. Sigma Arri HIP 13327. It looked like a planet. Or a moon, I have to say. So this is actually then the star, and this is Europa. And on the left we have Callisto here and Ganymede here. So okay, let's try to get surface details. I don't know if the red spot is out or not. So here we have Jupiter. Let's zoom in. It's still pretty close to the horizon. So definitely could probably use an atmospheric dispersion corrector. We can see, yeah, let's go to 200. Let's move it up. We can see the cloud bands. I can't see the red spot. I don't think it's out. So Jupiter has a rotation time of 10 hours, eh? So maybe it will come out later this night. Let's check. Maybe we just missed it. Oh, here we have a transit of Io actually in front of Jupiter, happening in front of Jupiter right now. That's always fun. I actually made a time-lapse video last year where I actually tracked Jupiter for about 3 hours with Io passing in front of Jupiter. That was a lot of fun to do. Also a lot of work to process all the data. So I'm not really seeing the red spot, but it is there. And Io should also be here somewhere. Let's see what we can do with the view. Up the exposure time a little bit and lower the gain. That might help. It's still very close to the horizon. As you can see, you see a lot of wobbling going on. Housemate Pauline is watching. Hello, Pauline. Yeah, AstroDoc. I was surprised to see that it was a star because I'm just used to seeing 4 moons, 4 Galilean moons, so I just assumed it was a moon, but actually it's the Sigma Aries star. So let me put it, yeah, let's take some captures as well. And let's see, what is my frame rate here? 140. Yeah, Jupiter is actually a lot brighter than Saturn. I noticed that now. So actually, it's like if I put it at like 250, maybe the gain. Here, I can even go as low as maybe 4 or 5 milliseconds. Now maybe not, because let's check out the histogram. That's always a good idea. So once again, it's not the best time to look at Jupiter, but of course it's always nice to look at the planets. Okay, 80%. I'm always aiming for around 80% on my histogram when checking out the planets. So I'm sure that I'm not overexposing a planet. So I'm at 6 milliseconds right now at 250 gain, and my frame rate is about 150. But I think Jupiter rotates like once every 10 hours, and it's a lot closer. So most of the time I end up with taking 1-minute videos of Jupiter. That would be my advice, at least. I have to check it out actually, if that's... I always take around 1-minute videos for Jupiter, because I think at one point you will actually notice the rotation when you're taking like multi-minute videos of Jupiter, and when you stack those images together, you again end up with a little bit of a blurry image. I know there are some programs actually to de-rotate Jupiter. It's like Jupiter Rotate. How was it? There was a very old program you can use to like de-rotate the different pictures of Jupiter and then stack all of those pictures together. Anyway. Yeah. AstroDoc, I think so. I already did, but you know, that is the case. I have like a 4-hour transit of Io in front of Jupiter already. So now the question becomes, do I want to go like through a 4-hour session again? And I think I want to do that again. I really like ending up with like a timeless video where you can see the planets rotate, but it takes a lot of time. So usually I would wait until like in November when Jupiter will be closest to Earth. So I'm sure that I'm getting the best image during that year. But anyway, if you want to do it, you can take like 1 minute videos, and then of course you can process all of these individual videos to a final picture, and then you will end up with, you can put all of those pictures behind, and you end up with a nice time-lapse video of a planet, and you can actually see the rotation of that planet. So it's always a lot of work, but also a lot of fun to process that. Shoop. So let me do another capture. So when can we expect to see Io then? Win Jupos, yeah, that's it. I think that's the only one, not a good one. I think it's the only program that derotates Jupiter. Or do you know another program? Win Jupos. I think it's like from the early 2000s. Do we see the red spot? It should be here somewhere. Oh, I'm experiencing a drop in my frame rate per second. And it's not at around 50. So I buffered some frames. Yeah. Yep. I think the Io is the one closest to the surface of Jupiter, right? To the planet. So quite often you will see Io. I think it's once every 2 or 3 days. It will move in front of Jupiter in its orbit around Jupiter. And then the other moons are not so. Are I don't know exactly. I think I can check out the orbital period, right? The orbital time. Does it say here? So I have Io. Let's check. Elongation, blah blah blah. Sidereal day, sidereal period here, 1.7 days. So once every 2 days, like almost 2 days, is one full orbit of Io around Jupiter. And let's check out the others. So for instance, Europa is the second closest, I think. 3.5 days, so once every 4 days roughly. And then we have Callisto, has is it 16 days, something like that, orbit, if I read this correctly. No, this is not Callisto. Where's that information? I saw it. Ah, it's so small, these letters. Blah blah blah, I can't see it. Mean sidereal day, mean sidereal period. Would that be it? It's like 16.6 days. But it says that Ganymede has a sidereal period of 7 days, so that's not it, I think. Anyway. 1 o'clock, guys, for me. I'm going to take some final images of Saturn. Oh yeah, that's what I wanted to check. So when will Io actually be visible again? Pretty soon. Okay. So it will come out like in the next 15 minutes. We will be able to see Io again. I think I will wait for that, and then I'll end the live stream. So guys, thanks for joining again. I like talking to you. Sometimes I hope I treat you well. So it's 1 o'clock for me. I'm not too active anymore. My brain at least isn't. It wants to go to sleep. I see the red spot. It's just a dark patch on the side. Yeah, great. You can't post links. No, that's true. You can go to my. I have AstroForum space. I'm an old-fashioned guy. So you can just go to my website and look at some of the images I'm actually proud of. It's like astroforumspace.com, and there's some like my photos kind of webpage where I put not all of my like a selection of my deep sky astrophotography pictures, and also I know that there are these. I think I have a 4-hour rotation of Mars. That was also quite a night to track Mars for 4 hours in the night sky, and I have a 3-hour rotation of Jupiter somewhere in there. And the nice thing about having your own website is that you don't rely on any social media. Like Instagram. I think Instagram wants you to post every minute. And I don't think that's what astrophotography is about, right? Posting your pictures every day. I mean, people get a wrong impression. They think that astrophotography, you can just snap a picture and put it online. But actually, if you do some dedicated deep sky astrophotography, you know that at least the capturing process is already maybe, if you use a mono camera, a couple of days, and then you need to post-process those pictures into a final image and integrate them. Some people who don't know what we are doing, they just write below it, they write, hey, nice shot. It's not a shot, it's like 60 or 75-minute pictures stacked together and integrated and post-processed into that image. So if you ever finish a deep sky astrophotography project, you should be proud of yourself. You should buy yourself, I don't know, a drink or whatever, some flowers, what you want. Treat yourself well. Compliment yourself. So this is, I think I'm starting to see Io now at the edge here of the disk. It's like a little bit below the middle on the right hand side, the bottom right here. I see something flickering. That's definitely Io. Cool. So we'll get to see the Io leaving Jupiter in real time. Let's do another capture then. Hogart, good night. Ganymede does have a shorter orbit than Callisto? Really? So that's then the correct information. Yes, Stellarium would have the correct so then Callisto is 16 days and Ganymede is only 7 days? I always thought that Callisto was the Ganymede was the furthest one, but then anyway, I will check it out. But anyway, the conclusion is that you're most likely to see Io transiting Jupiter if you're going to witness a transit, and then Europa once every 4 days. I know it would be nice. Maybe my next project would be hopefully having clear skies when two of these moons simultaneously, my English, simultaneously, I cannot pronounce that, pass the in front of Jupiter. That would be great to see two moons passing in front of Jupiter and leaving the disk of of Jupiter. That would be a great amateur astrophotography project or planetary project. 16.7. So there goes another capture. So we are now waiting for Io to reappear at the right hand side of Jupiter. Actually, nice to see. Oh. I hope that those are not the UK clouds coming to the Netherlands. I see a lot of wobbling. Let me check out that cloud radar. Yeah. It shows we still have clear skies, but there are definitely some clouds moving into the Netherlands. Okay, anyway, we will notice soon enough when there are clouds. So Io, where are you? Take care, Andrew. Andrew can't wait for winter. I have lots of, yeah. It would be nice to have longer nights again. I think in the Netherlands right now we have like a sunset at 9:30 and then at the 10:30 or 11 we have some proper dark skies again. And then until like 5 o'clock, something like that. So yeah, of course, I would like to witness one like autumn and winter where we don't have a lot of clouds, but unfortunately that will not be the case. So most of the time, I think when we get 2 or 3 clear nights or every month in November and December, that would already be quite something in the Netherlands. Sometimes we the whole winter passes and I can't see Orion, for instance. Usually it clears up again in February, March. Yeah. And then actually this in May we often have a very clear skies for a couple of weeks, and then after that we have a lot of rain again. But anyway, let's hope for the best. You never know. And I do like those longer nights. So it actually gives you time to set up your equipment and do some testing, and also image a deep sky astrophotography object in just one night, because you have like 10 hours of imaging. Anyway, I don't see Io yet. I thought I saw it, but it's here. I can't see it. I don't know if you can see it on YouTube. Yeah, I definitely saw it flickering here. I'm getting a little bit sleepy, but I will wait for Io to be free of the disk of Jupiter. So when I'm capturing Jupiter at 150 frames per second, my little desktop, my laptop, it's like a small form factor PC, which doesn't have a very high processing speed. It hicks up a little bit. Here it buffers 1000 frames. Maybe I should put a maximum to like 120 frames, see what happens. So, are you still awake? 20 people still. So yeah, if you're in the US, of course it's midday. Or maybe just the evening is just starting. So here in the Netherlands it's like 1:20, almost 1:30, 1:17 actually. Yeah, you can definitely, do you see it? I think so. You can see Io definitely here now. No, it hicks up again. I get about 5,000 frames in 1 minute. That's pretty good. But I have to buy a faster laptop, I think. Late is my time. Well, I know a lot of guys doing deep sky astrophotography, and once you automated your astrophotography, they just go to sleep and hope for the best. And you kind of have to when you have a job in the morning, right? So I'm free tomorrow, so that's nice. Need to sleep soon. Yes, Andrew. I see some flickering here. That's definitely Io. I want to see Io like independent from the disk of Jupiter. And then once I have that image or that video, I'm also going to take a nap. Because the astronomical seeing is not good enough to do some deep sky astrophotography at the moment. Unfortunately. Green Cat, you're retired. You lucky bastard. Or I hope you are. So let me put it back here. So once again, Jupiter, you can best image Jupiter when at opposition, which will be, I think, somewhere in November. I can check that out if you want. Let me see. Jupiter position 2023. So yeah, November 3. November 3 will be the closest point. The Jupiter will be closest to Earth at the beginning of November. So the distance right now from Earth to Jupiter, let's see if I can see it. But why is Stellarium not giving me bigger fonts? It's somewhere here, I think. Distance, distance, distance. Distance from the Sun. Distance, I guess distance from Earth. So 4.6 astronomical units. That's about 700 million kilometers, 690 million kilometers at the moment. But still, that's about half what Saturn is at the moment. Saturn is 1.3 billion kilometers away. So, will we ever be able to explore the asteroid belts and Jupiter with man-made aircraft or spacecraft? That would be interesting. WFH. Work from home, I guess. Ah. Yeah, commuting. I had several jobs at universities in the Netherlands, but they are. I live in Utrecht, and there's a university there, but I taught in Eindhoven and in Rotterdam, and then I had to go by train for about 1 hour single trip. So it was like 2.5 hours to go to and from, to go to work and commute back home. So yeah. It was actually that kind of thing about Corona was nice, that I didn't have to commute every day. But now I don't work full time. I have a couple of projects, courses I teach, but I'm kind of self-employed, so sometimes they hire me to do some teaching, and that gives me more freedom to actually enjoy astrophotography more. So yeah. It brings in a little bit less money, but more free time. That's always the trade-off you have to make. Start. So now I can definitely see Io here. I loved Corona. Nah. It was a bit of a scary time, but the working from home part and not having to be at meetings at night, in the evening, that part wasn't so bad. Two hours each way, yeah. So you spend a lot of time commuting then. I once met a guy in Japan who was a teacher there, and he had to commute like 3 or 4 hours. And he said, I get home at 12 o'clock at night or something at midnight, and then I have to get up at 4 o'clock, 4 a.m. again to get to work. That was crazy. And he mostly slept on the train, something like that. And he didn't see his kids. Anyway, we need to talk about astrophotography and not commuting. So here we have Jupiter and Io. I like it. I like it a lot, actually. So you can definitely, I can up the exposure time a little bit. So you can definitely, I'm overexposing the, oh, it's actually quite tricky. It's not so far from Jupiter. I hope you're able to see it when I'm exposing it at 6 milliseconds. It's here. Maybe up the gain a little bit. I get the similar results. 250 is the sweet spot. Oops. 250. Here we go. Histogram. 80%. Nice. So let me do 1 or 2 more captures here. If I put this on maximum, high speed is on. Yeah, nothing more I can do. Let's actually put Jupiter in the middle. Here we go. Let's do some. You can definitely see Io here, leaving the surface, the disk of Jupiter. Of course, it's not on Jupiter, it's moving in front of Jupiter. I don't know the exact distance between Io and Jupiter. Is it showing if I click Jupiter? It has a lot of interesting information. The diameter of Io is 3,642 kilometers, so it's about the same size as our moon, I think. Blah blah blah. Hourly motion. It only tells me the sidereal period 1.77 days. Distance. No, it's only distance from the sun and distance from Earth. So don't know the distance between Io and Jupiter. Yeah, that's true. There were less planes during Corona, so we had better imaging opportunities without all these plane streaks in our deep sky pictures. Oh, nice. Let me do one more capture. Oh, it's 5,000 frames dropped. For somehow I have some issues with my frames per second. I'm at 160 FPS, which is pretty good. But then it drops. I can also try to... Can I decrease... Let's see. Oh, that is very... but I only do 1 minute captures anyway, so why not? Let's try to keep it here. Exactly. So I reduced my region of interest. So let me press start and hope for the best here. Start. Trying to get as many frames as possible, and sometimes it also helps to just reduce the region of interest. So this is like 320 pixels. From left to right, I guess, width. So Jupiter is about, I have Jupiter at about, I think it's about like 200 pixels in diameter. And once again, I could use a Barlow lens to up that to like 400 or 500 pixels, but then my frames per second will drop. So there's that. And I'm already at 0.2 arc seconds per pixel, so I think the astronomical seeing is about, so it's not beyond that point. My English. I'm losing my English when it's so late. Maybe I can find it again in the morning. Oh, here we have captured 9,000 frames. That's a lot better. Oh, let's do one more. So if you have 10,000 frames instead of 5,000 frames per minute, of course you have like twice as many frames to select the highest quality frames from. So you probably end up with a better picture. That's my hope anyway. So let me try to do another capture here. So I have to be careful that the Jupiter stays within this region of interest. So Io clearly visible here. It's actually pretty big now. It appears pretty big because I zoomed 400% on that region of interest. So pretty cool view, this one. I'm getting excited again. I was falling asleep, but now that I see I/O and my FPS being at 160 per second, I'm happy again. My English is good. Well, for a Dutch guy. My English is pretty fly for a Dutch guy. Dun, 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 dun. Oh, look at that. That's not dropping many frames. It's almost capturing everything. 9,000. Again, 9,500. Wow. Maybe I should return to Saturn. No, but actually Saturn wasn't the problem because I had to expose that for 20 milliseconds anyway. So the frame rate was about like 50 or so. All right. Any more questions? Or remarks? What do you think? Is this a good idea to actually... I think you should reduce the region of interest as much as possible, right? I mean, you're only going to be interested in the planets, and you can always resize and resample if you want. I think frame rate per second is the most important thing. If you can up your FPS by reducing your region of interest, you should definitely do it. Will I stack this on stream? Yeah, not tonight. Sorry about that, Greek cat. But several reasons. The first reason is I'm just too damn tired to do it now. And the second reason is that I'm on my laptop. So actually there's this mini PC next to my telescope mount and it's on my network. And I'm actually showing you that image. Oh, you look at the turbulence now. The last one was a lot better. So I'm streaming this image from that laptop. I'm streaming the image from that mini PC that's next to my telescope mount. From my laptop to YouTube. And actually my imaging PC is... I have another PC to do my post-processing basically. So it has an Intel Core, like a Intel Core 7, how it's called? Processor. So yeah, that's why I cannot show you that right now. Maybe I should move that PC to my living room so I can actually show you some live post-processing. But I have actually 2 tutorials. They are already from about a year ago, but I didn't change my workflow too much. So if you look at AutoStacker tutorial Wido's AstroForum on YouTube, you will be able to see what I do in AutoStacker. And also I have a Registex tutorial as well, so you can check that out if you want. And I'm also happy to hear about your processing techniques, of course. So there's that last one wasn't that great, so I will do another capture. Hopefully the atmosphere will calm down a bit. It does not. I think I have at least one good capture. Massive planet. There's always this competition between Jupiter and Saturn on how many moons are in that system. I think it was Jupiter took like first place from Saturn at the beginning of this year in terms of the number of moons they could count, and now I think Saturn has retaken that place again. I read it somewhere. But I think the telescopes and the observation techniques keep getting better, so they are able to see these smaller and smaller rocks orbiting the two gas giants. So I was actually thinking about how small these moons would be. And in order to be a moon, I think you have to be perfectly circular or something. It cannot be an asteroid or anything. It needs to be a spheroid, I think, the moon. And of course it should orbit then the planet. Anyway. Okay, let's do one more. I can still see Io. It's drifting a little bit towards the right, so maybe I should start here. Noise. Yeah, what makes a moon? Yeah, I think it has to be spheroid. Spherical. How do you call it? Spheroid? Spherical? Without any significant peaks or something. I also read an article on there are some astronomers who, like planetary astronomers, they actually refer to moons as separate planets, like planet-like. Because when you look at like a moon like Io, it has a lot of volcanic activity, so it's active, it's a spheroid. But the only thing that doesn't make it into a planet is that it orbits a gas giant like Jupiter. Now, of course, that's then a moon, but there's still a lot of interesting activity going on, and still I think the moons, the Galilean moons, like Io, Callisto, Europa, and Ganymede, I think they are as big or even bigger as compared to Mercury. So yeah. But anyway, once you are going to start mentioning moons as planets, then we end up with like I thought it was like 50 or 100 planets in our solar system, and that would not be very easy to remember as in primary school. Anyway, but it would be great that if some of those moons got more popular, like talk about the ice moon Europa with a big ocean which might harbor life, or talk about the volcanic activities. The volcanic activity of Io is maybe more interesting as compared to talking about Mars, which is now a little bit of a dead planet. It used to, of course, be active, but anyway, I'm babbling because I'm tired. Oh, you typed something. Astroduck, you're still here. Thank you. Okay, yeah, the discussion about the moons. Moons orbit planets, planets orbit stars. Yeah, that's of course what it is. A moon is an object that orbits a planet or something else that is not a star. Are called satellites. Stars orbit galaxies. It never ends. It's also interesting to talk about like what's the speed or something. You have the rotation speed, and then you have the speed with which we move around the sun. But of course the sun moves around the center of the Milky Way galaxy, and then we have the local group, and then at one point it's all relative. Okay, you can call them moons. They are satellites, natural satellites orbiting another planet, but I just wish these moons would be like would get a little bit more known by the general population. So people now know that we have 8 planets in our solar system, hopefully, with of course Pluto being debatable, but Pluto is a dwarf planet because it's in the Kuiper belt, if I'm correct. And there are a lot of other icy bodies just like Pluto in the Kuiper belt, so that would be insane to call all of those similar kind of spherical objects, all call them planets. Anyway, there's a lot of debate about it. So this will be my final capture because I'm falling asleep. So just before I go, thank you so much for joining. And I hope you have a great night. I also hope you have some clear nights in the upcoming days. And yeah, if you're interested in planetary imaging, once again, Saturn is almost at opposition. That's why I started to live stream a couple of days ago, to let people know that Saturn is closest to Earth in 2023. So yeah, if you like to observe or image Saturn particularly, this would be a very good time to do so. And that's my final capture, 10 more seconds. So I will try to process some of these videos tomorrow or the day after, and I will put some pictures in the community stream. So you have on every YouTube channel you also have like a community tab, so I will post some pictures there, and also on Instagram if they are actually, if I like them enough. But definitely on the community tab, so check that out if you're interested in the final results of those videos I took tonight. And yeah, thanks for joining, thanks a lot, and maybe see you in another video or in another live stream. And I hope you have a good day and a good night. Hasta la vista.